Alright, we're back at Chauffeur Shop today, and here's a little experiment that I wanted to show you guys. This is the Venus Transit model. And I am very skeptical of the whole Venus Transit model, whether it was actually carried out like they say it was, or anything else, because it really, if you start out on a false premise, you're going to get a gobbledygook for an answer. So let's start with what we actually know. If we take a look at the Venus Transit model, what is rotating the fastest in relationship to the other bodies? That's the viewer. The person on Earth is spinning. That's the fastest moving part of the equation. So what I've done here, obviously you can see the sun. The little black dot is Venus. That is a pin. Now the camera is on I have a little thing I can spin. I'll show it to you in a sec. Real quick, I'll show you how I'm doing this. Just got the camera lined up with the two. We just got a little pin for a Venus and a ball for the sun. I just did this very quickly. It's sitting on top of my saw. So that's what I'm doing. And then this thing will spin. I'm just spinning the camera with this instead of using the turntable. I just wanted to see if I could get it to work. I'll put the turntable in there later and if necessary, but this does the trick, I think. Alright, in the northern hemisphere we are rotating counterclockwise, so alright, this would be clockwise, so we're going to come back the other way, and so here we go. None of these bodies are moving in space fast enough to be viewed. You would have to be still on the Earth for hours to watch the actual movement of the planet. What we're seeing is we're seeing our own rotation. That's what we're seeing. I think the trigonometry is out of whack. But I mean, you're measuring something, but I mean you're measuring some angle, but if Earth isn't revolving around the sun in the first place, especially at 107,000 miles per hour, the premise is wrong to begin with. So you can't even use that. If you use that motion of Earth as being like 1.6 times the diameter, okay, that gives you a longer triangle. That gives you a longer leg of the triangle. It's wrong. Okay, here we are. This is the Tychosium, and this is just before the Venus Transit in 2004. This is June the 7th. Make sure this is correct. Yep. Okay. Now, what I'm going to show is I'm going to run this at 1 hour. In other words, 1 second will equal 1 hour. And just try to line this up. So you're going to see, watch the Earth. Alright, watch the Earth's rotation. And you'll see that Venus really doesn't move. And you will notice, however, that the sun is moving. But these aren't to scale, so So the main thing we want to look at is just the revolving of the Earth. So let's run it. Now, clearly we can see Earth revolving, but you don't see any movement at all with the planets. So they have moved, but very little. So if we change this, if we go back, let's go back. Well, you can see as I step through it, it's more obvious because it's faster. So let's run it at, we're running at a day because it's the next best thing. So let's run that. So that's clearly an indication of the movement, but let's go backwards. Let's get right to the transit. And you'll see on the day of the transit, the planets are lined up directly in line. We go to an overhead view from the top. You can see they're directly in line. That's the beauty of the Tychosium. You can use this to see anything you want. I've taken out Mercury. The moon isn't in the picture either. But you can see exactly on the day of the transit, if you look at elongations, when they're directly in line, the elongation, as you can see on Venus, is going to be less than 0, well, less than 1. So I'll just step forward in an hour and you can see this change. It's 0.292 now, right there, you can see that. Step forward, it's 0.32, so we're getting a little further away, so I'll step backward. 0.29, 0.27, 0.275, 0.29, just getting a little bit bigger. So you can see that. And if I put this on minutes, I could go even closer, but 0.275 is just as about as small as you're ever going to see anything. So there you can see we're looking at the transit right then and there. And let's just run this and watch the Earth spin. So you can see the viewer is the one who has really all of the motion. These planets will take, like I said, they're out of scale, but it lets you see that the motion is really the camera's eye. It's the movement of the person on Earth.